Hi everyone. Welcome back to another Planetarium live stream. My name is Jessica. I am the director of the Planetarium, and with me tonight are two familiar faces, two of the students who work at the Planetarium with me, and I will let them introduce themselves. We'll start with our buddy with curiosity. So tonight we are doing another edition of Ask an Astronomer since it's been a while since we've done this. And tonight is going to be just answering your questions. Any of those questions that you just have been dying to figure out an answer to, leave them down in the comments for us and we will answer them as we see them. And, hopefully we can give you an answer. If not, we will probably look it up afterwards because we all want to know, I would say, if we get stumped by a question. But yeah, go ahead and start leaving those down below. But until we start getting some of those questions in, we each have some fun kind of current events that have happened recently in astronomy that we're going to talk a little bit about. And I want to say the biggest is probably Eli, what you've got. So do you want to start us off tonight? Yep, sure are. Eli, I think we might be having those audio problems again. Yeah, hold on, I'm trying to get it sorted out. Yeah, if those watching could you hear Eli just talking? Because it looks like I might be having those audio issues again.
Yeah,
Um,
I'm
oh,
on the plane. Oh wait, no.
oh, nope, I'm coming through there too. All right, let's talk again.
Testing, testing, 1, 2, 3.
Okay, I think you're coming through now.
It's the Streamlabs or OBS rather.
All right, let's just
Should I start over?
yeah, I guess we'll start. I'm sorry for those. It looks like we've just are, after months of no problems, we're starting to see a few technical issues on our end, but it looks like your audio is now going through again.
Okay.
So we'll just start over if you don't mind.
Yeah, no problem. So I know we've already seen these slides before, but just so I can give some commentary, I'll make it short. So the Crew 1 launch between SpaceX and NASA happened on Sunday night, and this was pretty big. It was originally planned for Saturday, but due to some weather restrictions, it was delayed, and the resiliency capsule, along with the crew, launched aboard one of SpaceX's Falcon 9 rockets at just before 6:30 Central Time on Sunday. And this was a really big event because it is the first fully operational crewed flight from NASA since 2010, since a space shuttle mission, and it's also the first time in history that an ISS fully operational mission has happened with NASA's Commercial Crew Program, which was an initiative to enlist private companies to fly astronauts to the International Space Station. So a pretty big step in the future of space flight. And then really quick, just recapping who was on or in the resiliency capsule. NASA astronauts Michael S. Hopkins, who is middle left or middle right, Victor J. Glover, middle left, Shannon Walker, far left, as well as JAXA, which is the Japanese Aerospace Exploration Agency. Astronaut Soichi Noguchi were on the flight, and they were at Kennedy Space Center for 10 days before the launch happened. After 27 hours of flying, this is the image of Crew 1 and the Resiliency successfully docking with the ISS Monday night. And the astronauts that that were aboard the Resiliency are scheduled to stay on the International Space Station until May of 2021, when they will depart aboard Resilience and return to Earth via splashdown. During their time up there, they will work alongside 3 astronauts from the Russian Soyuz MS-17 mission as they conduct experiments in microgravity. And one particularly important thing that I thought was worth noting, another piece of history was made because Victor Glover is the first Black astronaut to arrive at the International Space Station for an extended stay. So I thought that was a pretty cool thing too. Yeah, pretty big step.
I didn't know that. That's really cool.
Yeah, so pretty cool.
I thought you were about to say we were history with their zero-G indicator, but that was
No.
My thought was much less important than what you actually said.
Well, the zero-G indicator is funny too. Do you wanna tell them what it was? I didn't grab it, but I should have.
You didn't grab. Okay. Do we want to go back to us
Sure.
real quick? So for those of you who may not know, a zero-G indicator is basically um, a fancy name for a usually plush toy that the astronauts take with them so that they know when they have reached orbit because it'll start to float. Yes, Lindsay's holding the last mission's zero-G indicator, our little sparkly dino there. And this launches was Baby Yoda. And so you can see in some of the pictures of the crew as they're making their way to the ISS of little Baby Yoda floating around. And I was teasing Eli about that because he might be slightly in love with Baby Yoda.
Oh, yep.
All right. And I, again, apologize to those of you who've been here from the beginning where we were having some technical audio issues. It looks like we got that sorted out. Yeah, but let's keep going. I'm not seeing any questions for us yet. So another reminder, if you do have questions for us, as that is the theme of tonight, is Ask an Astronomer, make sure you leave those in the comments and we will get to those. But until then, Lindsay and I both also have some fun things to talk about. Lindsay, do you want to go before or after me?
Yeah, I can go now.
Okay, cool. Go for it.
Okay. Okay, so I kind of was researching some of the recent updates with one of Jupiter's moons, Europa. And there is a spacecraft that's getting ready to fly to Europa. It's called the Europa Clipper. So I just kind of wanted to show you guys, this is the website. It has some good images and graphics and stuff of what the Clipper is going to be doing there. So it's going to be looking for different evidence of what could be in the ocean of Europa and on the surface.
I'm so excited for this
Different
mission.
visions, yeah, of what the surface could look like. So this is what some of the surface looks like, and there are actually some spots on Europa that have names, and I actually didn't know that, even though Europa is one of my favorite moons. So this crater must be called Quill, and some other features there. But what's really interesting about Europa is what is on the inside. So there's this iron metallic core, and then a rocky interior. And they think that there are things that are radiating in the metallic core. There's radiation happening, and that's heating up the rocky interior. That happens on Earth also. And then they think that that is causing enough heat to have this ocean, liquid ocean. Another thing that is actually probably more contributing to the heat than the radiative elements is the tidal heating with Jupiter and the other really big moons. So Jupiter's gravity is pulling Europa towards Jupiter, and the other really big Galilean moons are pulling Europa in the opposite direction. So it is caught in kind of a gravity tug of war, and the insides get kind of rubbed together, and that friction is creating heat. And so we are pretty much 100% sure there's a liquid water ocean here, not just because we think that the tidal heating could be making this icy surface liquid underneath, but also we see evidence of water seeping up through cracks. So that we wouldn't see that evidence if there wasn't some liquid water under the surface of Europa. So this is what the Clipper looks like. And just real quick, it's a flyby orbiter. It's still in development. It still says that the launch date is going to be sometime in the 2020s. So hopefully that's true. And they can still get it out before the end of the year. And then there is a video here about kind of some of the different things that the Europa Clipper is going to be looking for.
Let's start talking about the mission. The mission is called Europa Clipper, and it's a collaboration between NASA and the Jet Propulsion Laboratory in Caltech and the Applied Physics Laboratory at Johns Hopkins University. Europa Clipper is designed as an orbiter to perform multiple flybys of Europa to comprehensively study all areas of the moon. The spacecraft will be 6 meters, approximately 20 feet high, with huge solar panels measuring 22 meters, 72 feet across. And to talk back to Earth, Europa Clipper will be equipped with a 3-meter, approximately 10-foot high gain antenna. Orbiting Jupiter once every 2 weeks, Europa Clipper will perform a total of about 45 close flybys. The spacecraft's altitude above Europa will vary from 25 kilometers, 15.5 miles, at the closest point to 2,700 kilometers, 1,677 miles at the farthest point. NASA is sending Europa Clipper to help scientists and astrobiologists answer big questions in science. Therefore, the mission has clear and concise scientific goals. 1, determining the characteristics of the subsurface ocean alongside looking for water in the moon's outer shell and measuring its thickness. 2, studying chemical components in Europa's atmosphere and their origin. 3. Measuring Europa's magnetic field and determining its various parameters. 4. Studying geological activities on the moon and its surface features and looking for suitable landing sites for possible future missions. 5. Investigating Europa's capabilities to host life as we know it on Earth, which provides progress into astrobiology.
Okay, and there is a new thing that could
Let's
be
start
going
talking
on Europa that an experiment has just been done on, and the people who are running the Clipper spacecraft are going to try to see if they could try to study this. But so astronomers, we're looking at Europa, and so all this brown stuff on the surface is organic molecules. And Jupiter has a lot of radiation and particles that are going really fast. And they were kind of thinking to themselves, what would happen to these organic molecules with this radiation and high velocity particles coming from Jupiter? So they set up an experiment to try to figure that out, which is kind of unique because usually in astronomy, like we see the weird stuff out in the solar system and then we try to replicate it in the experiment in a lab, like the hexagon that you can see when you look at the North Pole of Saturn, the hexagon in the clouds. We tried to replicate that in a lab. Well, this we're replicating in a lab and then we're trying to see if it actually exists. So they found, so in the lab, they had their radiation and high moving particles that you would have from Jupiter. And then they had a simulated Europa icy surface that they think has all of the stuff, the same kind of molecules and things that Europa would have on the surface, including table salt and also magnesium sulfate. And they found when they bombarded this surface, simulated surface with particles as fast as the ones from Jupiter, that it did actually light up. And they also tried out different types of molecules in different surfaces. So they tried a couple of different compositions of icy surface that could possibly be on Europa, and each different composition actually lit up in a slightly different color, which is kind of cool. So we might be able to use that to help us kind of figure out a little more exactly what is in the surface of Europa. We won't be able to see this on the day side of Europa because the sun's light is too bright, but on the night side of Europa, which of course we can't see from Earth, unfortunately, could be glowing up like this all the time from Jupiter's radiation. So I think that's pretty cool.
That is really cool. And all of this is hopefully leading up to one day having a spacecraft land on Europa and actually explore that ocean below, which I really, really, really hope happens in my lifetime because I want to see that. I want to see little alien fishies discovered.
Mm-hmm.
Like, it's going to be cool.
Yay.
All right. I'm not seeing any questions. Eli, sometimes you see ones that I don't. No? All right. Well, again, if you do have questions for us, leave them in the comments. But I will start talking about a couple of the cool things that I found. So, oh, it looks like we did just get a question.
Yeah, just noticed that. Mm-hmm. At 5:30 a.m. this morning, my husband saw a bright light going over Lake Superior, and it looked like it would almost go into the lake. Do you know what that could have been? It was going towards the harbor. Well, we are in the peak of the northern torrids right now.
And
so,
I think the Leonids.
Was it? We did this on the last live stream too.
We did. I know, and I forgot to get dates again.
I think it was the northern torrids that we're in right now.
And I have my notes from the last show, but most likely that was a meteor, especially if it is the northern Taurids. They are notorious for making particularly bright meteors, which we call fireballs. And that,
like a week ago, we're in the peak of the Leonids right
yeah, which is best seen before dawn. So that is very likely what it was. It was a Leonid meteor.
now.
There are also always satellites up. I was just looking. It doesn't look like there was an ISS, the International Space Station, passed last night. That's usually the brightest. But sometimes there are iridium flares that light up the satellites pretty bright too.
Yeah. So either of those is a very likely possibility. But yeah, we've been getting we've heard from a couple of people who have seen some rogue meteors over the past couple weeks, which is great because we are kind of in a couple of meteor showers right now. Not super busy meteor showers, but still some cool ones that you can still see some pretty good meteors from them. All right. So all right, so the first thing that I wanted to talk about is about a planet that has been found. Now, this is pretty different than other planets that you may have heard about, because typically when we talk about finding a planet, we have found a planet orbiting around another star, which is probably the only thing you think of with a planet. A planet that goes around, a planet is something that goes around a star, but it turns out that that is not always the case. There are these things called rogue planets that are wandering through the universe, not orbiting around a star. And we have found some of these. And it's pretty cool how we can find them. Let me bring up my slides. Oops, that one. There we go. So we use this effect called gravitational lensing to find them. Basically, what this is matter, like a planet, warps and distorts space-time around it. Let me loop this. There we go. And so it acts like a lens. It can cause light to look from a star to look brighter than it is for a short period of time. And so if you have a rogue planet pass between you and a background star, you will see for a short time that star temporarily get brighter and then dim back down to its usual level. And we can tell that this is a gravitational lensing because this brightening happens for all types of light the same. If it was some random fluctuation in the star's light, we might see red light act differently than blue light, for example. But that's not the case if it's this lensing event. And so with this sort of thing, we have found quite a few planets, but we typically find really big planets because they have more mass and they create a bigger, better lens. And so they're easier to see that brightening that they cause because they cause a bigger brightening event. But with the one that we just found is actually turns out to be an Earth-sized rogue planet. So there are, it appears, rogue Earths out there. This is so far the smallest rogue planet that we have found, just because the smaller the planet is, the more difficult it is to detect. But I just thought it was really cool that not only do we know there are these rogue planets, but there could be actual Earths flying around. Now, they're not going to be warm because they don't have a star's light to keep them warm, but that doesn't necessarily mean they can't have life, because you could have a situation like Europa where you have an icy crust, but enough heat inside the planet to keep some of that ice as water, to keep it as an ocean. So it is feasible that you could have rogue planets with life on them, which is even crazier, I think, to think about than just another planet around a star with life. Now you may be wondering how we get these rogue planets. And let me actually flip back to my face since I don't have another picture yet. So when planets form, that's a pretty chaotic event. What happens is you have lots of dust and rocks and debris around a young forming star that sticks together and gets bigger and bigger and bigger, and you collect bigger and bigger objects. And when this first starts, you have quite a lot of material there, and you end up forming a lot of planet-sized objects. Well, some of those are close enough together that they might hit each other, which could knock one of them free of the solar system. Or you could just have gravity from one planet fling another planet out. And so our very own solar system probably formed some planets that are rogue right now, flying through the universe, not attached to our sun. So this is a pretty common side effect of the chaotic environment that planets form in around stars. And I just think it's really cool. All right, the next bit of news I have is not as cool or, come on, switch, there we go, or as happy of news. So you may have heard that the Arecibo telescope is in a little bit of trouble. So this is a giant radio telescope that is in Puerto Rico and has done some amazing work. Back in January, after already going through a major hurricane, they started having lots of earthquakes in Puerto Rico, and the people who work at Arecibo became concerned about the integrity of the structures after all of these major events. But things seemed to be okay until August. On August 10th, there was one of the cables slipped out of its socket, and as it became unhooked, we'll say, it caused a lot of damage to the facilities that you can see here that are suspended above the main telescope dish. It also gouged out, you can see it here, this damage, a huge 100-foot long gash in the main disc of the telescope. And that was, in and of itself, devastating news, but something that seems like it could be fixed, because this cable that snapped or came unhooked was not one of the primary cables. It was one of the secondary, one of the kind of backup cables. But unfortunately, bad luck has continued, because on November 6th, a second cable snapped at Arecibo. This one is one of the primary cables. And this cable snapping has completely compromised the structural integrity of the telescope, and made it even more difficult to fix, because this is attached to that big platform that we saw above the main dish, which makes it dangerous to get up there, and that's where you need to get to fix these things. So the fate of Arecibo is unfortunately kind of up in the air right now. We are not sure if we're going to be able to fix this, and that is devastating news, because Arecibo has done some amazing work in a lot of different fields. You may know it because of the Arecibo message that it sent out. It was an encoded message to any other intelligent life out there that may be able to receive that and know that we're here and how to find us. But it's also done lots of other work other than beaming messages to potential aliens, everywhere from studying our own galaxy, studying planets around other stars. I'm scared, and I am hoping that this can be fixed. But I don't want to end the night on completely devastatingly sad news. So the last thing I want to show you is our lovely Curiosity rover on Mars has taken yet another selfie. And so this is the newest image released by the Curiosity team. It was released about a week ago, actually. And so here we have happy little Curiosity. So Curiosity landed on Mars back in 2012. And it landed in an area on Mars called Gale Crater. And it landed here because we had long suspected that this was a potential place where there may have been liquid water once on the surface of Mars. And so far, Curiosity has proved that to be absolutely the case. Gale Crater appears to be an ancient lake bed, where there used to be a system of lake and a stream system connected to it long ago, back when Mars was warmer and wetter. And it's really cool. One of the ways it's actually testing all of this is it has a little laser drill that drills holes into the rocks, and then it analyzes the vaporized rock that comes out from that drilled hole and looks for certain elements and molecules that are generally found in the presence of liquid water. So lots of really cool things happening with that. And it's getting a new buddy. Why am I forgetting? Perseverance. Yes, Perseverance. Should be there in, I think we're under 100 days now. And we'll have a new rover on Mars, which is going to be cool. All right, that's all the news I have, and it looks like we are at time. We will take one last call for any other questions that you may have for us. But while we see if any of those come in, let me tell you about this next upcoming week. So on Saturday, Lindsay is going to be doing the history of spaceflight, telling us about the amazing women who helped get us off the Earth and explore the universe, many of whom are probably never heard of, unfortunately, but that's why we do this show. And then after that, we are actually taking Thanksgiving week off. So next week we will not have shows on Wednesday or Saturday, giving our staff a little bit of a break for the Thanksgiving holiday, and then we will be back the next week for the start of December with our What's Up December and Constellation Story Time for December. I also just want to say that we are still selling our stellar distancing t-shirts to help raise money for the planetarium, since we have been closed since mid-March. All of these proceeds go to help us continue to do these live streams and also allow us to do things for the communities like our Stellar Saturday events and to host virtual field trips for schools. All right. Well, that is all I have for us tonight. I'm not seeing any other questions come in. So thank you everyone for joining us. We hope to see you Saturday for History of Spaceflight. Otherwise, have a wonderful week, and we will see you another time. Bye, everyone.